So we wish that in addition to clicking on the canvas, when we moved our mouse over the canvas with the mouse button held down, we would draw points. So how can we achieve that? So we had in our main function, we had this canvas on mouse down, run click. So there's also, turns out there's a function on mouse move, and we can just tell it to click whenever the mouse moves. And then we should get something pretty close. So let's take a look. Oh, well, I'm not holding the mouse button right now, but I'm drawing some things. So this is not quite what we wanted. So let's take a look at why this is happening. So I'm going to comment this out and move to a slightly more complicated version. So on mouse move, I've changed from just naming the function click to putting an anonymous function here. So this function doesn't have a name. It takes the event, and then it's going to check something about the event and then call click if it's true. So it turns out there's a field in the event called buttons, which is set to 1 when there's a button held down. And then if there is a button held down, then we're going to go ahead and call our click function, the same one that we were using before. So let's try it with this version. So now I don't draw until I hold my button down. And when I let go, I don't draw and I can move around. So this is more the behavior I want. So the key thing that happened here is that we just checked if the button was down before we actually call the click function. So now there's another thing to notice. So I'm drawing, and it's getting slower and slower and slower. And it can almost not update at all. So what's going on with this? Well, notice I've added this. I'll show you how I added this in a little bit. But notice this has the numbers of dots. So when we don't have any dots, we're going fairly fast. And then as we start to get more dots, when we get more than about 100, everything is starting to slow down somewhat. So this seems natural. We're drawing more things. Of course, we wish we have better performance. We'll come back to that in a little bit. But let's look first at how we figured out what's going on with our performance and what's happening here. So we added some calls into our rendering function. So let's go down and take a look at the rendering function. So in our rendering function, first we need to find out how long is it taking to draw. So this is measuring how long is it taking to draw. So we're going to get the start time. There's, I searched the web and found this. Your book doesn't say it. If you call performance now, you get some time for you starting. And if we do our draw all of our shapes, and then get to the end, and then again check performance now, and subtract the original time, we have the duration that we took. And that duration is in milliseconds. And then we wish that we could take this information and somehow put it on the web page. So we'll go into the details of this in a second, but I've written a function here which sends the text to the HTML. And what is the text I'm sending? The text num dot, and then the length, which is the number of dots which is the number of shapes that we have to draw, and then the milliseconds, and then just showing the duration. So now we need to look at how does this sendTextToHTML function work. So here it is right here. So this sendTextToHTML function is going to go get some element from the HTML document using an ID. These are the same IDs that we had. So red button, green slider, whatever, these kinds of names that we gave to our things. And then, and print some error if we can't find it, right? And then set the innerHTML to whatever the text was. So we've taken two parameters. We've taken some text and some HTML ID. So if we go look at our call to this, we have a string. And then at the very end of this, our second parameter is num dot. So we should expect there to be an ID num dot. So let's go back and look at our HTML. So indeed, I've added a paragraph here, which has an ID num dot. And I've set it to just be XXX in the beginning. So let's take a look at what happens when I reload this page. So here's my fresh page. Here's my XXX that's on the page. This is the text in the paragraph. And we've now set, and because we've given it an ID, we can reference this paragraph. So then in our JavaScript, we're able to go get that ID and then go change what that text is. So in all, what's happening? We've changed our render shapes so that we check the performance, and then we can print out something about this performance. And this can be quite helpful for adding feedback into your system. For debugging, if it's just for debugging purposes, then I might open the console down here and print into the console. There's commands that you can just do a console print from your code also. But if you want to see it live on your page, then this is a way that you can get to that. So nevertheless, that we can print out what the speed is, why is it getting so slow? What's going on here? So we don't have so many dots. I have less than 300 dots. And my frames per second's gone down to 10, and it's gotten really laggy and not performing very well. This is super annoying. We can't be writing graphics programs if it's going to like this. So what can we do about it? Now again, this is something the book doesn't say, but we've figured it out, and here I'm telling it to you. So if we go to our setup WebGL, this is where we first declared our geo context. This is what you have in your code right now. We're going to change this. We're going to add a flag to this. This is, you just have to consider it the magic flag. What does it do? It's telling the GL context something about which buffers to preserve rather than reallocating them and clearing them in between. So if we change this piece of code so that we do something different, let's reload this page. So now when I draw, my milliseconds is 0, and I can get nice smooth motion, and everything draws fast. Now, will this be the same on every browser? I have no idea if this is the same on every browser. I'm on Windows 8 in Chrome, and this is the way that it's behaving. So you're going to have to experiment a little bit. However, this trick of adding this option onto declaring the WebGL buffer is able to enhance the performance in my case.